this video, we will be talking about function notation. And when we're talking about function notation, it's important to remember that f of x, g of x, k of x, h of x, z of x, whatever we have of x, is the same thing as y. But sometimes the function notation is more convenient than just putting a y. And that will be the case for this whole video. So here we have g of x equals negative x squared plus 4x plus 1. And we want to find g of 2. So what we're going to do is everywhere that we have an x, we're going to replace it with a 2. And that gives us negative 4 plus 8 plus 1. That's going to be 4 plus 1 gives us 5. So g of 2 is 5. Pretty simple. So let's do something a little bit different. We have g of t. So now we're going to plug in a t everywhere that there is an x and simplify. So we have negative t squared plus 4t plus 1, and that is our final answer. So far it's been pretty simple. Here we have g of x plus 2, which means we have to plug x plus 2 in everywhere that we have an x. Okay, and so now we have to multiply this, so that gives us x squared plus 4x plus 4 plus 4x plus 8 plus 1. I went ahead and distributed my 4. I need to distribute this negative. So I have negative x squared minus 4x minus 4 plus 4x plus 8 plus 1. Combine like terms, these will reduce, and we're left with negative x squared plus 5. So whenever you have a binomial that's being squared, you have to remember to multiply appropriately. Now let's plug in g of x plus h. So we'll have negative x plus h squared plus 4 times x plus h plus 1. Again, we're going to have to multiply here, so that gives us negative x squared plus 2 xh plus h squared plus 4x plus h, 4h plus 1. We have to distribute this negative here. So we have negative x squared minus 2xh minus h squared plus 4x plus 4h plus 1. And none of those are like terms, so that is our final answer. We need to know how to find f or g of x plus h whenever we're doing something like this, which is called the difference quotient that you will use later on in calculus for derivatives. So what we need to do here, we need to find g of x plus h minus g of x and divide that by h. We already have it, so there's no need to do it again. So we have negative x squared minus 2xh minus h squared plus 4x plus 4h plus 1. Now we're going to say minus, and make sure you put parentheses around your entire g of x. Negative x squared plus 4x plus 1 all over h. What I'm going to do is simplify the top some more. So I have negative x squared minus 2xh minus h squared plus 4x plus 4h plus 1. This will now be a plus x squared minus 4x minus 1 all over h. If you notice, we have negative x squared and positive x squared, so those are going to reduce. We do not have another term like this or this, but we do have the opposite of this one. Don't have another one like this, but we have the opposite of this one. So we're left with negative 2xh minus h squared plus 4h all over h. If you notice, we have a common factor here, so I'm going to bring that out. I'm left with negative 2x minus h plus 4 all over h. And then we simplify, and our final answer would be negative 2x minus h plus 4. So that would be the difference quotient. It's a long problem. It's a long process. process, but it's very doable if you just stay organized and keep your steps in a neat fashion. Alright, so that's function notation for a polynomial. Let's look at function notation when we're dealing with a piecewise function. This is a piecewise function because it has two pieces. We use this when x is less than 0, and we use this when x is greater than or equal to 0. So here I have f of negative 1. Negative 1 is less than 0, so I'm going to plug negative 1 into that first equation. I get 1 plus 1, which is 2. So my final answer there is 2. F of 0, have to be careful on this one, but equal to 0, we use this here. So we would just say 0 minus 1, and we get negative 1. F of 1, we're going to use this one because 1 is greater than 0, so 1 minus 1 is 0, and then f of 20, that's greater than 0, so we will just plug it in here. We'll say 20 minus 1, which will give us 19. So a piecewise function is not tricky, you just have to read the directions and follow them. Our last problem that we're going to work, we have k of x equals the square root of x squared, and we want to find k of 2c. So we're going to have the square root of 2c cubed. You can go ahead and work with that. So that's 8c cubed. Alright? And then we know that we can simplify this. We can rewrite 8 as 4 times 2. So we have 2 times the square root of 2c cubed. We can take 2 away from this, so we could have our final answer to be 2c times the square root of 2c. If you want, you could leave it here, but your teacher probably wants you to bring it down to here using exponent rules and simplifying radical expressions.